So good evening, everybody. Welcome back. Welcome back to another session. So today is day 3. So we will be discussing on the EDA and data pre-processing in oceanography analytics. So before that, let me rewind 1 minute what you are discussing on the day 1 and day 2. We'll recap as fast as. So on the day 1, we have learned introduction to ML AI in oceanography analytics. So how an AI and ML will useful for oceanography to humans in any ways. So this was the introduction on the day 1. So on the day 2, we have learned what are the data types, what are the business movements, all those things. What is business understanding? What is data understanding? So all these things we learn in the day 2. In the day 2, we also learn what are the data types, how many data types are available. Excuse me. On this day 2, we have learned data types and all those things. So today we will learn on the EDA and data type processing. Yeah. So before starting, we will learn one by one what will be there in the EDA, all these things. So today's agenda is EDA, exploring data analysis, and what are the data pre-processing, all these things. Yeah. So here we will be exploring on the data analytics and in data pre-processing in oceanography analytics. Then we have text pre-processing and then pre-processing techniques. So what will come under in EDA? Nothing but exploring data analysis. So first we will start with what is EDA. So what is EDA? EDA is nothing but exploring data analysis. So it is used by data scientists and data analysts to analyze and investigate data sets and to summarize the main characteristics and often employing for data visualization methods. So it is used for both often employing and data visualization methods. So this is a easy way for the definition of the EDA. Then we have types in the EDA. We have univariant, multivariant, and multivariant graphical. So yeah. So we have types of exploring data analysis in the ADA that are univariate non-graphical, multivariate non-graphical, and univariate graphical. We also have multivariate graphicals also in the EDA. So exploring data analysis was promoted by the John Turkey to encourage the statistical to explore the data and possible formulate the hypothesis that might cause a new data collection and the experiments. So EDA focus on the more narrower on checking assumptions. So it will check the assumptions required for the model fitting and hypothesisly testing. So it also checks while handling missing values and make transformations of variables as needed. So EDA builds a robot's understanding of the data. So it issues association with either info or process. So it is a scientific approach to get a new story of the data. So we have four, I'll write here one by one. Is the, yeah. Next. First, we will learn about univariate non-graphical. So univariate non-graphical, this is the simplest form of data analysis. So as during this, we can use we use just one variable to research. So here we use just one variable to research. So the standard goal of univariate non-graphical EDA is to know the underlying sample distributions. So data make observations about the population. So the outliers detection is additionally part of the analysis. So the characteristics of the population distribution includes central tendency, spread, skewness, kurtosis, all these things. So we have central tendency. Then we have spread. Then we have third one is skewness. Skewness and kurtosis. Yeah, we have only three things. So this was in under the invariant non-graphical things. Then we have multivariant graphical. So multivariate non-graphical EDA, technically it is used usually want to show the connection between two or more variables. So within the sort of the either cross tabulation or the statistics. For category data, so an extension of the tabulation called cross tabulation. So it is extremely useful. So well, let us take for two variables. Cross tabulation is preferred by making a two-way table with some columns headings so that matches the amount of one variable and row heading that matches the amount of the opposite two variables. So then filling the count with all subjects so that shares an equipment pair of level. So for each categorical variable and one quantitative variable, we create statistical for quantitative variables, separation for every level of the specific variable, then compare the statistics across the amount of the categorical variable. So when we comparing the means is an off of the curve version of the Aveno and comparing medians. So maybe a robust version of one way in ANOVA. So this was about the multivariant non-graphical. Then we have univariant graphical. In this, we have 1 minute. Yes. So let me explain what is the univariant graphical. So it is a non-graphical method are quantitative and objective. So they are doing not giving the complete picture of the data. So therefore, graphical methods are more involved a degree of subjective analysis. So it's also required. So common sort of unvariant graphs, they are histogram. Then we have stem and leaf plot. Then we have box plot also. At last we have volatile normal plots. So let us start with the histogram. So the foremost basic graph is the histogram in the EDA. So which may be a bar plot during which each bar represents the frequency. So or the proportion of a case for a variety of values. So the histograms are one of the simplest way to quickly learn a lot of your data. So including central tendency spread, modality shape and outliers are shown in the histogram. So as in the stem and leaf plot, so it is a substituted, easy substituted for the histogram. So maybe stem and leaf plots. So it shows all the data values, and therefore the shape of the distributions will be stem and leaf plots. So in the box plot, another very useful univariate graphical technique. Sorry. Yeah, so in the box plot, so another very useful univariant. So box plots are excellent at the presenting information about the central tendency and shows robust measures of the locations, and spread also as a providing information about symmetric and outliers. So although they will be misleading about aspects like multi-modality, one of them is simple use of box plot is within the sort of side-by-side box plots. So in the quartile normal plot, the ultimate univariate graphical EDA technique is the most intricate. So it is also a quality called the quantile normal or QN plot as more. So generally they quantile or QQ plot. So here so quantile normal plot also called as QQ plot. So it will be easy to understand all these things. So I have made this drawing. It is like a little bit of mind map, so you can understand which is related to these things. At final, we have multivariant graphical. So multivariant graphical data used for graphical to display with relationships between two or more data sets of the knowledge. So the soul and used commonly may be group bar plot. So within the each group representing one level of one of the variable or every bar within a gaggle of representing the amount of the opposite variables. So here we have some scatter plots, run charts, heat maps, multivariant charts, bubble charts. So in the multivariant chart, it is a representation of graphical representation of the data visualization. So that displays the multiple circles like bubbles. Sorry, it is a graphical representation of relationship between factors and response. So in the bubble chart, it will display visualizations in the multiple circles like bubbles. Then in the last, we have null shells. So we thought all to always perform appropriate EDA before further analysis of your data. So perform whatever steps are necessary to become more conversant in your data. So check the obvious mistakes, learn about the variables distributions, and study about the relationship between the variables. So EDA is not an exact science. So it is a very important are the tools. So for EDA, we need some tools. So the tools will be Python, any language tool for analysis. Here here is a small explanation on the experiment data analysis. So experiment data analysis is referred to as critical process of performing initial investigations. So on the data, so as to discover patterns, to spot anomalies, to test hypotheses, and check the assumptions with the help of the summary, statistics, and graphical representation. So here EDA stands by asking some basic questions to data sets. Make the initial assignments of the data structure and quality of facilities. Sorry. So here they are. So is there any existing unique record in it? So are fields populated with numbers or data or alphanumeric characteristics? So what is the distribution of numeric values? So how many values exist for categorical fields? How many fields have been left in the blank? And we have how many multiple data sets are related. Here, as we discuss about the graphical analysis, univariant, bivariant, multivariant, all these things. So we will be learning about the statistical analysis in a meanwhile. First moment business decision, second, third, fourth, all these things through our mind map. So let's move to the mind map. So here is the mind map. So here in this we will move to the data pre-processing. In the data preparation, I think we have done with data preparation yesterday. So we will be looking into this first moment business decision. Yeah. Yeah. So what is the first movement business decision actually? So the measure of tendency are also called the first movement business decision. So to begin with, I would like to elaborate why this is important. So while we first get the dataset to work with, we usually check for which features of datasets are important to use and whether they are numerical or categorical. So the first movement of area of a shape about a certain axis. So the equal to sum of over all the individual parts of the shape of the area. So the first moment of area is commonly used to determine the centroid of the area. Give me a minute. Yeah, so in this we have mean, median, mode. So median is also called as the average. So it gets the influence outliers in the measure of tendency. In the median, we have middle most value of the data set. So median is the middle most value of the data sets. So it does not get inflected by the outliers actually. So the median of data set is the position where it divides the data set into half, provided the data in the ascending orders. So to calculate the median, so the first order the numbers in ascending order from small to big. So if the total number of the total number of in the data set is odd, then the number exactly in the middle is the median. So the total number in the data set is even, then take the two numbers that are exactly in the middle and average them to find the median. So median is always preferred by many analytics as it is more accurate to the despite the center of the data available. So in the mode we have mode of the data set is a number which occurs most of the time in the data sets. So here there are some two steps. So we have to calculate the frequency of occurrence of each value in the data set. Then mode is the value with highest frequency. Mode is very less commonly used in the codes. So this was about the mean median mode. Then we have second moment business decision. So second moment decision is nothing but measure of dispersion. So the moment describes the spread of data points around the mean. So it speaks about how far the data points are distributed away from the mean. So in that we have variance. So variance is it measures the difference between each data points from the mean. Then we have standard deviation. So square root of the variance refers as the standard deviation here. So in the variance, units are also getting square. So to bring the normal form, need to calculate the square root of the variance. To get the value in the normal unit and not in the term of a square. So standard deviation has come into existence. At last, we have some range. So the difference between the maxima and minima of value of the data set is nothing but the range. So this was about the second movement business decision. In third, we have skewness. So skewness is the measure of asymmetric in a distribution curve from the normal distribution. So it is representing a normal distribution curve with any skewness. So if A is negative skewed curve having the most of the right side of the curve and has long tail extending in the left side. So is a positive skewed curve having the mass on the left side of the curve and a long tail extending toward the left side of the curve. So this was about the skewness. Then we have fourth business moment. Here we have kurtosis. In the kurtosis, so kurtosis is an estimation of the peak of the curve. So it's measure if the data is lightly or heavily tailed from the normal curve. So the curve, the high kurtosis value incident in the presence of the outlier. This was about the fourth movement business decision kurtosis. Here we also have graphical representation, as I informed before. Univariant, bivariant, multivariant, all these things I have explained just now. So this was about the EDA. In this pre-processing point of view, here we use text preprocessing. So it will be legal text analytics involves automatically extracting segmentation information from the archives of the case decisions and converting the statute using Ligris. So for this, we use various tools like BRT space and NLTK. So after extractions, the data sets needs to be proceed various process are their tokenization, normalization, and noise removal. Here we have some pre-processing. So based on the general outlier and various steps under the each component are so they are remove HTML tags which remove extra white space, convert accent characters to the ASC double line. So it expand the constructions, remove special characteristics. Then we have lowercase alt texts. Then we convert number word to the numeric word. When we remove the numbers, remove the stop words and lematizations, all these things. There in the data pre-processing, here the other pre-processing techniques they are typecasting, handling duplicate outliers, analysis and treatment. Then we have zero or near zero variance, discretizations, missing values, dummy variables, creations, transformations. Then we have string multiplication at last. So we'll learn one by one what is this. To understand the data processing, we have to know how all these functions will work. So we start with type casting. One minute, guys. Yeah. So in the typecasting, what do you mean typecasting? So the typecasting is when you assign a value of one primitive data types to another types. So in the Java, there are two types of casting. While doing casting, automatically converting a small types to a large types. So it's basically a different way of changing an expression from one data types to another. It's known as data types. Sorry, typecasting. Then we have handling duplicates. So while fetching such records, so it makes more sense to fetch only unique records. Instead of fetching the duplicates record, the SQL distance keywords, which we have already discussed, is used as a conjunction in the select statement to eliminate all the duplicate records and by fetching only the unique records. So how do we handle duplicates data? So select the range of the cell so that has duplicate values and you want to remove. So remove any outlier or the subtotals from your data before trying to remove the duplicates. Then click the data, remove duplicates, and then under column and check the data before trying to remove the duplicates. Then click the data, remove the duplicates, and then under columns, uncheck the column whether you want to remove the duplicates or not. So this is about the handling duplicates. Then we have outlier analysis and treatment. In the outliers, uh, Yeah, so the outlier analysis is a process that involves identification the anomalous observations in the data sets. So let us first understand what outliers are and what are the outliers are nothing but an extreme value so that deviates from other observation in the data sets. Then we have zero or non-zero variance. So here zero variance means all observations are equal. So it is simple. If the variance is zero, then all the numbers must be same because there is no variations here. So variance of zero variance, zero indicates, sorry, so that all of the data values are identical. All non-zeros are positive. A small variance indicates that the data points tend to the very close to the mean and each other. A high variance indicates that the data points are very spread out from the mean and from the another. So this was about the zero or near zero variance. Then we have discretizations. So what does the discretization means? So the act or the process of making mathematically discrete. So the process of dividing a geometry into finite element to prepare for the analysis is called as discretization. So what is the discrimination in the data mining? So discretization is the process of putting values into the buckets so that there are limited number of possible states. So the bucket themselves are treated as the order and discrete values. So you can discretize both numeric and the strong columns. So there are several methods and you can use to discretize the data. It's called as discretizations here. Then we have missing values. Here in the missing values, how can someone find the missing values here? So there are some steps to follow to find out the missing values. So step one is count how many elements are there in the data set. Then multiply the mean by the number of the element found in the data set. Then subtract all the known values from the product obtained from the steps two that we discussed. So what are the types of missing values? So here we have missing data are typically grouped into three categories. So they are missing completely at random, MCAR. When the data is MCAR, missing completely random. So the fact that the data is missing is independent of the observation and unobservation data. Then we have missing at random and missing not at random also. So after converting this, we have dummy values creations. So dummy variables is a variable that takes value from 0 to 1 when the value indicates the presence or the absence of the something. Let us take an example. 0 may indicate a place and 1 may indicate it's a drag. So in the regression analysis, so dummy variable also known as the indicator variable or just dummy. So one that takes the value 0 or 1 to indicate the absence or the presence of some categorical effect that may be expected to shift the outcome also. So the dummy variables or the indicator variable is an artificial variable created so to represent an attribute with two or more distinct categorical levels. Give me a second, I will be back. So here we have transformations again. So we'll be discussing on the transformations. So transformations is a dramatic change in the form of appearance. Let me check the mic is on. Yes. So a transformation is a dramatic change in the form of appearance. So an important event like getting your drive license, going to college, or getting married can be cause a transformations in your life. So a transformation is an extreme radical change in the data preprocessing. So some common synopsis of transform or convert, so transfigure, transmography, and transmute. So while all these words are meant to change a thing into a different thing, it transforms implies a major change in the form of nature or in any functions. So in this, we have some types of transformations. First, we have data collection. Then we have data organization. And the third one is then we have data. Integration also. Data reporting. And finally, we have so here some of the steps for transformations. They are data collection, data organizations, data processing, data integration, and data reporting. Then we have data utilizations. So these are the some stages of the transformations in the preprocessing technique. So what is a data transformation example? So let us take an example. So as the term implies data transformations, so it means taking data stored in one format and converting into another. So as a computer end-to-end user, you probably perform basic data transformations in a routine batch. So when you convert a Microsoft Word file into a PDF, so you are transforming data. So it is called as transforming data. So this was about the transformations. Then we have standardizations. So standardization is a process of developing, promoting, and possible mandating standard based on compatibility technique and processing with given industry. So the standard for techniques can be mandate the quality and consistency of the technology and ensure their compatibility, interoperability, and safety. So this was about the standardizations. So what is for UT is used for? So the goal, what's the goal of the standardizations? So the main goal of the standardizations is to ensure uniformity to the certain practice. So within the industry, and standardization focus on the product creation process and the operation of the business and technologies in use. So and how specific compulsory process are instituted or carried out. So this was about the standardizations. So once I will show in the mind map. Yeah. So you can go through sorry, what I call mind map. You can see all the topics as covered in it. So we have discussed about the typecasting, handling duplicates, outliers, zero and non-zero variance, missing values, discretization, dummy variables, transformations. Here we have standardization or normalizations. Then we have string manipulation, so which is nothing but unstructured textured data. So it is called tokenization, which is stemming limitations, which is stop word removal and document similarities. So decide the topic methods also in the manipulations. So this was about the manipulation. we have done with all this for movement decision means. We also have called starting for the invariant, bivariant, multivariant. So in the event we have all these things: bar plot, index plot, dot plot, strip plot, violin plot, stem and leaf, candle plot, pie chart, time series plot, histogram, density plot, box plot or box and whisker plot. Then finally we have pupil plot, also called as quartile quantitative plot. So we have completed the business movement distance and graphical representations. So we have done with this movement business decision, all the 4 movement business decisions. So when we move on to the coding part, here first we have to before starting all these things, let me explain about a little bit about the Python and the libraries. Okay, I will explain here. Yeah, so in Python we have some libraries, pandas, numpys, cbones. So all this, by using these libraries, we make a code for the for the histogram or for any visualizations tools. So you can download the Python through the Anaconda. So it is a free, you can download through net. So here, first we have to load the required libraries. So what are the required libraries for this? So they are import pandas as PD. So we are giving pandas as PD here. As same as for the NumPy, we are giving NP. For cbone, we are giving SNS. So when we load the data, we type here D is equal to PD.read CSV file. So DF nothing but data frame. PD nothing but pandas. So when you read the CSV file, here we have to keep the data location. So when we keep here, it will extract all the data here. So when we view the data, we have to type here df.head. So this is about the basic information. So when you want to describe the data, we type df.describe. Or else when you want to find the duplicates, we type df.duplicate.sum. 1 minute. Yeah, we have covered data pre-processing. So we will see what we have not covered in the data. Yeah, we have not covered the feature engineering. So in the feature engineering, we have first we have feature engineering on temporal data. So in the temporal data, we have the database features and we have time-based features also in the feature engineering of temporal data. Then we have feature engineering on the numerical data. Here we can see raw measures, interactions, binarizations, rounding, binning, and we can see statistical transformations also. In the categorical data, in the feature engineering, we have transformations, nominal features, and transforming ordinal features also, and encoding categorical features. In the text data, we have bags of words model, and we have bags of n-grams models, document similarities. In this, we can have, in the text data, we can have topic models or word embeddings. And in the image data, what is image data? So in the image data, excuse me. Here we have image metadata feature from the EXIF file, EXIF data, or we can call it the raw image or channel pixel, or in binding imaginary intensity distribution also. So here we have image aggregation statistics, edge detection, objection detections, or localized feature extractions. Then we have visual bag of word model. So this was about image. The features extractions, we have automatic extractions, manual extractions, and final principal component analysis. In the feature selections, here we have filter methods. So what all the filters will be there in the methods? Grappling methods, embedded methods, we have threshold based methods, statistical methods, and regressive features eliminations, and model based selections, sub selections methods also. The sub selections we have best sub selections. Forward step selections and backward step by selections. Yeah, so this was about the pre-processing. So these are some techniques I have explained here. So I will explain about the ML in the ML and EDA process. So let us take an use case. So many of the sampling methods used in the oceanography science today the date back decades, if they're not centuries, all through there has been marked change in how sampling for chemical oceanography. So it's carried out still releases. Yeah, so it relies on taking the sample water from the research vessel and assessing process on the small times as well in transient event required. So both the requirements can only be adequately satisfied by the C2 sensors. For physical parameters of the shelf instrument are available in the field of chemical oceanography. So only a few parameters such as oxygen are covered by the self instrument. But the most parameter instrumentation only exists in the form of prototype. So if at all, chemical in situ centers are needed to gain new insights in how the oceans and the life in it works. So this paper will give an overview of several technologies used for development of chemical in situ sensors for the last 5 years. So, and what is the potential these techniques have been for the future? So these technologies covered are optical absorptions for nitrate measurements from the low micromolar to high concentrations. So as we know, ocean process span a vast range of scales, both temporal and spatial, from the sub-second and the sub-millimeters scales from the molecular process to the climate change, decades and oceans bias to investigate the wide range of the process. A large volume of data has to be gathered from this harsh environment. So for us take in chemical oceanography, so the measurements task is to exacerbate by the low concentrations of many measurements, often in the presence of relativity high concentrations of compounds chemically similar to the measured, good specificity, low level of detection, high presumptions, and accuracy of measurements. So these requirements were traditionally Only made by taking water samples. So for analysis, either on the board or the research vessel in the home laboratory, it's a widely recognized. So that for variety of scientists question, this method is inactive in that, so it does not provide the necessary data for understanding the underlying processes. Many parameters of internet vary wide in the time and space cannot be characterized by the infrequent fixed interval sampling. In that we have data integrations. So let us discuss few points on the data integrations. So the common use in the C2 chemical sensor is expected to lead to a marked increase in the volume of the data for chemical parameters. So accordingly, a new method must be developed to process this data. So physical oceanography has long been dealing with the high data rates and robust methods for the data handling and storage are well established for the profiling measurements as well as mode. So these operations of ocean observations with their great numbers of sensors then we also have quality assurance in the use case. How we can use in this ML and AI.